Hi everybody. Hi everybody. Today we are going to start a new topic, that is motion in straight line. So I will be discussing three type of motions. One will be a motion in one dimension. A second one will be motion in two dimension, and the third one will be motion in three dimension. Then we say that a motion in one dimension. So what means it's only a straight line path, you can say, or you can say like in our previous chapters also we discussed this thing this we means we should be aware of this thing this is x-axis, this is y-axis, and this one is z-axis. Okay, so if the motion is in any of these coordinates, any of these axes, you can say. So it's a one-dimensional motion. Means if it's moving like this, if a car is moving in x direction only, in x direction only, so that's a part of one-dimension motion. Okay. Now, what will be two dimension? So, in case of two dimension, I am considering any of the two axes. Either it may be xz, xy, or xz, xy, or yz. Any of the dimensions. So here I am considering only xy. So if the motion is like such that means you can consider it like this. If a motion is such that the path or the coordinates of it, you can say, that contains x and y, you can say, means the motion is in both towards both axes, you can say. It means if it's x and y, in that case it traveled x distance, you can say, in x-axis, and y distance in y-axis. So it's a two-dimension motion, you can say. If a body is moving in such a way so that means it falls in a, you can say, in x and y axis, any of the two axes, you can say, then we say it's two dimension. So here it was traveling only in one of the axis, so it's one dimension. Here it's traveling in two axis, any of the two axis of this coordinate system, x axis, y axis, or y, any of the two axis. And if the motion is such that like x-axis, y-axis, and z-axis. Suppose it is moving somewhat like this, and the coordinate of this point is x, y, and z. So it clearly shows that it moved some distance in x-axis, some distance in y-axis, and some distance in z-axis. Okay, so this is What is called motion in one dimension? This is what is called motion in one dimension. In case of one dimension, it will move in any of these axes. Either it may be purely, means purely it will be moving either in x axis, purely it will be moving either in y axis, or purely it will be moving either in z axis. Then that's a one dimension, because it is moving only in one dimension. What are these? These are dimensions, you can say. Okay, so it's x axis, y axis, and z axis. If it is moving in two dimension, you can say, means any of the coordinates, so it clearly shows that here body is moving like this, you can say. So at some point the coordinate of this is x and y, so means it traveled x distance, you can say some distance x in towards x axis, some distance towards y axis, means y distance towards y axis, like this one is x1, this one is y1. So this one is x1, this one is y1. Okay, this means in x axis it travel distance x1, in y axis it travel distance y1. Okay, if it's like here the coordinate is x2 y2, so in x axis it travel distance x2, and y axis it travel distance y2. So it's only two dimension we are considering. Okay, when the motion is such that it means the coordinates are like this, x, y, and z, means it suppose it's x1, y1, and z1, you can say. So this means that it traveled x1 distance along x-axis, and y1 distance along y-axis, this one, and z1 distance along z-axis. So this is, here we are having three dimensions, you can say. So means x, y, z, all three we are considering. So this is what is called motion in three dimension. So like suppose example of this you can say in one dimension is motion of a car. In this case you can say like some particle is moving along the circle, you can say circle in circular path is going on, so it's a two dimension because here only x and y axis are there, so it's a two dimensional motion, you can say. This is circular motion, you can see. So it's a two dimensional motion. There is one more thing you will come across, that is projectile. So that is also a projectile we will come across in this chapter only. So that is also a two dimension part, because here we are considering this one is y axis, this one is x axis. So these type of motion which have only x axis and y axis, so that's a part of two dimension motion. Okay, now we will be discussing two more things. One will be, you can say, distance, and then other one is displacement. Suppose this one is initial point, and this one is final point. A car starts from here. First it went here, then it here, and then after some time it reaches here. Okay, so this the length of this path, from initial to final point, the length of this path is called distance. And what is displacement? This is the shortest distance between the two, or you can say the directly line joining between them. This is the shortest distance. This is what is called displacement. Okay, so its original path is this one. Means it traveled like this car traveled from, means this much of distance it traveled. You can say like this. But so distance is total distance traveled, that is this one. And what is the displacement? Displacement is this one. You can say the shortest line joining or shortest distance between the initial and final point, or you can directly join a line between initial and final point. That is what is called a displacement. Okay, so distance is a scalar quantity. What scalar quantity means? It have only magnitude. Okay, and what displacement is? It's a vector quantity, because it have both magnitude and direction. So consider something else also, like this is our x-axis, this is our y-axis. Okay, so the initial position, you can say that is this one. That's a position vector we discussed earlier, so it's a initial position. And after time delta t, it reaches here. That's the final position, you can say. Means particle started from here and ended here. Okay, the position vector of this is r2. So this is, suppose the path it traveled, this one, suppose it moved like this and it reached here. So what will be displacement here? Displacement will be this one. This one will be the displacement. So in vector form, what would be the displacement? And like it, suppose in delta time t, what is this? Time taken from initial position to final position. From initial position to final position. So what will be this one? This one will be, displacement will be displacement vector will be, means that you can say r21, r21, r2 minus r1. Okay, this is r21. So this r21 is the displacement. Okay, it's the displacement vector. So in vector form, it's denoted like this. Here it is shown like this. Now you can see here that distance is always more than displacement, you can say. You can see here that distance is more than displacement. Okay, Suppose it's our initial point, it's our final point, initial point, it's our final point, and car traveled like this. From here it started in a straight line and ended here. Started in straight line and ended here. So in this case, this will be the displacement and this will be the distance. So both distance and displacement will be equal in this case. Means magnitude of displacement will be equal to displacement, magnitude. It have only magnitude, distance have only magnitude. It have magnitude and direction. Okay. So both distance and displacement have equal, or you can say for the time being that both distance and displacement will be equal in this case. Here distance will be larger than displacement, means in this case distance is greater than displacement. Okay, I put it here like this modulus sign because displacement is a vector quantity, and by the help of this we can show the magnitude. So you can say distance is greater than, you can see it by your eyes, like it's more than this distance. If you are going to measure it, it's more than this distance. It's more than this distance. Okay. So this distance, you can say in this scenario, this distance is more than displacement. But in this scenario where car started from initial point and ended here, it's moved in a straight line. So here you can say displacement is equal to displacement modulus. I am putting here, that's a magnitude, is equal to distance. Okay. So this is what is distance and displacement. Now I will be discussing speed and velocity. So here in case of speed, we will be considering the distance. You can say distance. Here we will be considering the displacement. Like earlier we discussed what is distance, what is displacement. Distance is what? Scalar quantity. We discussed it earlier. And what is? Because it have only magnitude. And what we discussed for about displacement, that is vector quantity. Means it has both magnitude and direction. So what speed is distance traveled by object in unit time. Distance traveled by object in unit time. You can say here that we are using distance here. What will here be? Means it will be displacement covered by object per unit time. We wrote here unit time. Suppose if something is given like 5 meter per second, what is this? This is speed, or you can say magnitude of. One more thing is there that as it is using, you can say distance here. Okay, so it is also a scalar quantity. Speed is also a scalar quantity. As distance is scalar, speed is scalar. Because and what about velocity? Like you can see here displacement. We are using displacement. You can see here displacement covered by object per unit time. So it's a vector quantity, you can say. So velocity is vector quantity, displacement is vector quantity, and speed is scalar quantity, distance is scalar quantity. So what I was discussing, like suppose speed is given speed is given 5 meter per second. So what it shows, like you can say 5 meter it traveled in 1 second. Like speed, if it's given 5 meter per second, so what does it mean? It means 5 meter it traveled in 1 second. 5 meter per second is the speed. What does it mean? 5 meter it traveled in 1 second. Okay. So you can say that, you can see here like so you can see here we are using distance and here we are using displacement. So that's the main difference between velocity and speed. Okay. So if speed is given like this, you can say if speed is given 5 meter per second, like speed is given 5 meter per second, and 5 meter is what? 5 meter is distance. If you can say if velocity is given 5 meter per second, so what it means? It means that the displacement is 5 meter. Not distance is 5 meter, displacement is 5 meter. If velocity is given 5 meter per second, so it means it covered 5 meter displacement in 1 second. So got it? Or we can also say it's a formula. You can say speed is equal to distance There is one more concept, that is average speed and average velocity. So SAVG, it shows the average. So what I told you, like speed is equal to distance traveled over time. So like total distance traveled, you can say total distance traveled over time interval. This is what is called the average speed. And what is average velocity? VAVG we are writing here. Total displacement. Here we are using distance. Here we will use displacement. So you can see here like we can denote it like this, total distance traveled. So we are going to denote it like this, delta S, that's the total distance traveled, you can say, over delta T. Why we are using delta here? You can say let that is used for donating, you can say denoting this distance travel, or it's a time interval, you can say. Like if someone tells you like if someone says you like, suppose initially the car is at a distance of 5 from this origin, and finally it reaches 8 over here. So what will be delta S? That's delta S will be equal to 8 minus 5. 8 minus 5, that's equal to 3, because it's equal to 3. And like at you can say that t is equal to 5 second it was here, and t is equal to 10 second it was here. So what will be delta t? So 10 minus 5, that is delta t, you can say. Okay, so this is what is here as a, you can say delta S and delta T. Similarly, like it's a distance here, so it's a scalar, so this one is also scalar. So you can see here the thing is that it is, this one is displacement and this one is distance. This one is distance and this one is displacement. You can see here, I wrote it here. So this is how we are going to calculate the average velocity and average speed. Because this thing is that in this case, in the case of average velocity, we will be considering the displacement. Okay. The third thing I am going to discuss, that is instantaneous, instantaneous speed and instantaneous velocity. Actually, it includes a part of your math section. In maths, a limit thing is there that you will come across in your maths books. So I won't be going into detail of it. Uh, for the timing, you can say that the speed of an object at a particular instant means at any particular time, the whatever is speed. So speed, you can say speed at any particular time. That is what is called the instantaneous speed. And velocity at any particular instant, any particular time or any particular instant. So that is what is called means that is what is called instantaneous speed. So you can say that speed of an object at a particular instant is called the instantaneous speed. Means at like uh, you can say suppose this is our initial point, this is our final point. So at this instant what would be the speed at this instant? So this is what is called means when we calculate, when we are going to calculate the velocity at this instant, speed at this instant. I'm talking about this instant. Means it's the initial point, it's the final point, it's moving from here to here. But at this particular instant, what would be the speed? That is what is called the instantaneous speed. And when the scenario is for instantaneous velocity, it's the initial point, it's the final point, and body travel from here to here. So when someone asks you what would be the velocity at this instant or any place, any means in this whole path, any like here I want to know what would be the instantaneous velocity. So when we are going to find the velocity of any particular instant, means suppose this is initial point I, this is final point F, and at K I want to find out the velocity instant. At K instant what is the velocity? So we that is called an instantaneous velocity. So how we are going to calculate it? Like I told you, like suppose distance traveled here is ds, and whatever distance it traveled in dt time it traveled this distance. Suppose I want to find this one. You can say na, this one. So at this instant, suppose it traveled a distance ds. Actually, you will come across this differential element. These are called like ds, dt. You will be using these things in your calculus part, differential calculus. So these are called differential element, you can say, or differential distance. Means here what is, you can say small distance. We are denoting it means very small distances when we are considering. Then that we denote it by d. You can say it's d, ds. And suppose very small interval of time, you can say that's a differential element. What why we use the word? That will come in your calculus part when you are going to study uh, differential calculus and integral calculus. So Like suppose here it traveled ds distance because it's a very small distance and it's a dt time, very small time. So distance. So what will be the instantaneous speed? As instantaneous, we are going to write is equal to ds over dt. I told you that speed is equal to distance differential. You can say differential uh, distance over differential time. It's a small distance or a small time. Don't go in this word differential because that will confuse you. So for the time being, it's ds over dt. Okay, so we will come across a calculus section also, calculus part also, because we will be using it in our theoretical as well as the numerical part. There is another representation also, like that's a part of differential calculus. There is limit also in calculus. Limit. You will come across this thing limit in your calculus part. So there is no need to worry because you will come across all these things in your maths part. But the thing is how to solve all these type of things that we will take care. Means I'm going to tell you that how you are going to solve these type of problems, so that we will discuss it. So this is one representation of instantaneous velocity. There is another representation also, like limit delta t. Like here I told you delta t tending to 0 and it's delta s over delta t. This is another representation of instantaneous velocity. What is this delta s over delta t? That's the average velocity we saw here. But here what we are doing, that limit delta t tending to 0. It means that delta t is very small. It's near to 0. That's why we wrote here like dt. They're very small element. Very small element, you can say. Okay. Similarly, here also v instantaneous will be whatever displacement for this, you can say ds over dt. In the same way for limit also we can represent it like this: limit lim delta t tending to 0, again delta s over delta t. Okay, this is what your average, this is what your average velocity. And what in this case of average velocity, this time interval, this delta t. This delta t, it's very small, means it's near to 0, means it's very small. It's not 0, but it's near to 0, you can say. It is such a small delta t. Okay. So this is what is called instantaneous speed and instantaneous velocity. So suppose this is a circular path. This is a circle. And some or you can say a car. a car is moving in this direction. Suppose it's a 5 meter per second. It's moving. Here also it's 5 meter per second. Means throughout you can say 5 meter per second. 5 meter per second. So it's velocity speed. This speed 5 meter per second is same throughout. So you can say its speed is constant. Its speed is constant. But the thing you might be seeing that here the direction is of this velocity is this one. Here the velocity direction is this one. Means here also velocity direction is somewhat like this one. Here it's this one. Here it's this one. So you can see here that the velocity direction is changing. Direction is changing. So as speed is what? A scalar quantity. Here we consider only what? Magnitude. But what about velocity? It's a vector quantity. It's a vector quantity. Means it have both magnitude and direction. Okay. So speed is constant. 5 meter per second here, 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 everywhere throughout the circle its speed remains same, 5 meter per second. So speed is constant, but velocity velocity is not constant, because there what velocity is contains both magnitude and direction. Direction is not same. Like here direction is upwards, here direction is somewhat like this, here direction is somewhat like this, here direction is different, here direction is different, here direction is different, here direction is different. So speed is constant but velocity is not constant. Okay, velocity speed is constant but velocity not constant. Why it's not constant? Because direction is changing. You can see here its direction is changing, its direction is changing, its direction is changing, here it's changing, here in this circular path. Magnitude is same, magnitude is same, magnitude is same, this is what is magnitude, but direction is changing. Direction is changing, you can see here. So velocity is not constant, speed is constant. Okay. So you can write it like this: speed is equal to distance over time. Okay. So what will be the distance? Like from here it started. Uh, from this point it started and it moved from here to here to here. Again, come back to this point. So what will be the, and after you can say time t, it come back to this point. So what we know that speed is equal to distance upon time. So what will be the circle, like 2 pi r? 2 pi r is the circumference, that is what distance traveled. 2 pi r over t. So this is speed we are talking about, speed. Speed is equal to 2 pi r over t, where t is the time taken from, like it started from here and here and here and here and here, again it comes back here. So In this way we can find out like this 2 pi r over t, but 2 pi r, what this 2 pi r, 2 pi r is the, you can say, the path. Suppose the radius of this is, circle radius is r, so what will be, I think you might be familiar with this thing, 2 pi r is the circumference path. Okay, so so we'll discuss about non-uniform motion and uniform motion. Like suppose it started from this point, ended this point, starting point, end point. Okay, so like here you can say it started with velocity, speed is equal to, you can say speed is equal to, you can say 5 meter per second. When we saw the speed here, you can say here also its speed is equal to 5 meter per second. At any point, you can, when we are going to measure the speed, you can say it's 5 meter per second. So, okay, so like at any point, the velocity or speed, you can say it's 5 meter per second, 5 meter per second, 5 meter per second. So that is a uniform motion because the speed is, you can say, constant. It's moving with constant speed. So it's a uniform motion. Okay, like it's a starting point, it's a ending point, start point, end point. Like initially its velocity was 5 meter per second. Here it's 6 meter per second. It's 7 meter per second here. At the end, let it be 8 meter per second. So you can see here that its velocity is increasing. It's not constant. Okay. So this type of motion where you can say either it may be increasing or decreasing. Okay. So means speed changes with time. Like with time it's changing. You can see here. Here it's constant. So we said it uniform. Here it keeps on changing. So we said it's non-uniform. Okay. So it may be like there is a word called acceleration. Okay, so if the speed is increasing, if speed is increasing, then we can say that the body is accelerating. Okay, if speed is decreasing, then we can say it's deaccelerating. So in next class we are going to discuss this thing in more detail. So for the time being, I think it's enough, and we'll discuss new things in our next class. Yeah, for the time being, it's enough, and we'll discuss more into it, more in motion in straight line in our next classes. So that's all for today. Thank you.